To process data with Python, you need to be familiar with several basic Python data types. In this video, we'll discuss numerical and string data types, string operations, methods, and formatting strings. Python has a suite of built-in data types. Some of them can be grouped as numbers or sequences. We'll be going over a lot of these types as the course progresses. Today we'll talk about numbers and the first sequence type listed, which is strings. The values on the right are setting the X variable to an example of each of these data types. Strings are categorized as sequences because they're a set of characters one after another. In the example X equals Ken, it's surrounded by quotes. Each data type has a set of possible values, a set of allowable operations, and other properties like mutability, which we'll return to in another lesson. Integer has a range from -2 billion or so up to +2 billion. Let's look at some examples of allowable operations, what we mean by allowable operations. So I wanted to point out that a lot of the examples in the slide use the command prompt to show that they're being typed in an interactive window, so that you see the 3 greater than signs, which make up the Python prompt, followed by a space and followed by the code that's been typed in. And then the next line that follows will be the response from the Python interpreter. So when you see those 3 greater than signs, don't think of them as code, think of them as the Python prompt. In this example, A and B are being assigned integer values, and C and D are being assigned string values because they have quotation marks around 5 and 6. So in the first example, we add A and B, or we put the plus sign between A and B, and we get a response of 11. In the second example, we put a plus sign between C and D, and we get a response of 5, 6 in quotation marks. And that's because the items on either side of the plus sign in the first example are integer types, and those on the C and D are string types, and the plus sign has a different kind of operation associated with it depending on if you're using it between numerical values or strings. Another example, we have B ** 2, and that is taking B to the second power. So we get a value of 36. We're squaring 6. In the bottom line, you see D ** 2, and that returns a type error because this operation is not defined for strings. So you can't take the string D to the power of 2. There are 4 numerical data types: integers, floating points, complex, and long. The floating point you may be familiar with as a decimal number. If it has a decimal value in the number, then it's a float. If it doesn't, then it's an integer, or complex if it has a j. So the j is used to represent the square root of -1 in Python. The long, we don't use this very often, but just to be aware that the long is the same as an integer, but it has a wider numerical range. So you use that only when you need to deal with very, very large numbers. Notice the tip in the corner here. You cannot use commas within numbers like you do when you're writing, writing a paper. So this number will not be interpreted by Python as 1 million. In fact, it'll interpret it as a tuple, and we'll be getting to that in another lesson. So these are the addition, subtraction, multiplication, and division operations. We already talked about the exponentiation, 2 stars followed by any number that you want to raise it to the power of. The modulus division uses a percent sign. So the modulus takes the first number, divides it by the second number, and the integer remainder is the return result. So we mentioned before that Python has dynamic typing. If you set a variable to a value that has a decimal in it, the variable's type is float. Another point to be aware of is that in all versions of Python that are less than Python 3, so the version that we're working with, because ArcGIS is using 2.7, is the integer division. Okay, so integer division truncates any values after the decimal. So let's look at this example. We set a equal to 7, and because it's dynamic typing, it says, oh, that's an integer type. And then we set b equal to 7.0, and we use the built-in type method, and it returns float. Then if we divide b by 2, we get a number close to 3.5, which is what we would expect, 7 divided by 2. But if we divide a by 2, we get 3, and that's because of the integer division has truncated the values behind the decimal. Moving on to strings. As we mentioned earlier, a string is a data type for storing sequences of characters. There are two terms that we often refer to as string literal and string variable, but they're different things. A sequence of characters surrounded by quotation marks is a string literal. A variable with a string literal value is a string variable. So the difference between these two terms is important, and you can see an example here where we're using an assignment statement. The item on the left is the variable and the item on the right is the literal. Just to emphasize this point, a string variable is the thing we have on the left, and a string literal is what we have on the right. And printing a string variable prints the value of the variable. Printing a string literal means printing that string literally. So once you set up your string variable, say output equals this file path, don't use the quotation marks around the name. Use the variable name without the quotation marks to reference the value. So if you say print output, you get the file path. If you say print output with quotation marks around it, you get the word OUT-PUT. To create a string literal, you can use single, double, or triple quotation marks around a set of characters. But the opening and closing marks that you use must be matching. So for example, you can't use a double quote at the beginning and a single quote at the end. This will give you a syntax error. If you need to embed quotation marks, they have to be different from the outer ones. So for example, this "don't do this either" statement is going to confuse Python because it thinks that the string starts before the D and ends just after the N. And it doesn't know what to do with the rest of the string that's on this line. So if you want to have a quotation mark of some kind on the inside, you have to use the different kind on the outside. So if you're using a single quote like "I'd" in here is using, you have to use double quotes on the outside. Strings can contain numbers with special characters, although we'll see later that some character combinations have special meaning within a string. Start and end quotes have to be on the same line, except if you use triple quotes or a line continuation character. And we'll talk about line continuation characters in a moment. If you use triple quotes, you can continue typing the string on the next line. If you say quote ABC and hit the return key, you will get a syntax error. There are 3 uses of the backslash character. In Python, you sometimes do need to use very long strings, especially in geoprocessing. For example, the spatial reference, when written out as a string, can be very, very long. So you'll notice that when you put the whole string on one line, which is what we just said that we need to do, you'll probably have to scroll left and right to look through your code. For this reason, the Python programmers have a convention of limiting their line width to around 90 characters so that you can scroll up and down without having to scroll left and right to see all of the code. You'll see that here we're finding the number of characters in the spatial reference string. This len function finds the length, and there are 158 characters. So this is way over our ideal limit of character length. So if we try breaking up this string like we have it here in the PowerPoint, the Python interpreter can't understand it. It says this is a syntax error because the string doesn't start and end on the same line. So one way to solve this problem is to break the string up just as you want it and then use line continuation characters so that Python will be able to know, okay, when I hit this, I'm going to continue with the same string, and I hit this again, I'm continuing with the same string, and here's the end. So a string must start and end on a single line, or use a line continuation character at the end of the line, or use triple quotes. So what's the difference between line continuation and triple quotes? They both allow a string to be written on more than one line. These examples show the difference in what you're getting. If you use line continuation, you're preserving the line spacing so that it's considered an all one line string. If you use the triple quotes, you would use that when you want to actually have the output be printed on separate lines or be returned on separate lines. Here we have the example A, B, C, D, E, F, G, H, I in both of these, and here it prints it all on one line with a space after the C because we put the space there, and a space after the F because we put the space there. And here we have A, B, C, D, E, F, G, H, I, each on their own individual line, because that's exactly how we wrote it when we wrote these triple quote string here. On to the second use of the backslash. When a backslash is used inside of a string literal, inside of quotes, and followed immediately by a character, unlike our line continuation, which is at the end of the line. This signifies that what follows can take on an alternate interpretation, which is a set of escape sequences. So if we put backslash in a string literal, then we are telling the string that we want a new line. So in this example, we're trying to say that our data is in the directory C:national data /national data. But when we print this result, we can see that it interpreted the /n as a new line, so it's a sequence, the slash followed by a letter which has a special meaning. A /n is an escape sequence for new line. A /b is an escape sequence for backspace. /t escape sequence for tab. And // is an escape sequence for backslash. We have different ways to work around this problem. We can use the /, and this is what you'll see in most of the examples preferred. We can use a double backslash because that's escaping from the escaping from the slash, so that it'll be interpreted as a slash. Or we can use a little r right in front of the string literal, and that will be interpreted as a raw string. It'll say ignore any of the things that you see as escape sequences in here and take it as what the letters are. So this comes up a lot because we're working with data paths a lot. A little bit more about the raw strings and another type of string, which is a Unicode. It's another built-in data type. Unicode string that you'll see coming up in upcoming lessons. In this example over to the right, we have a R in front of the variable A, and we print A and we get C/temp because it's interpreting it as a raw string, and we say B equals C/temp without the little R in front, and we get C:, lots of space, imp. That's because \T, remember, is interpreted as a tab. Sometimes you actually want to use those tabs and spaces to format your print statements, but if you're using file paths, usually you want to use the raw string. So you can do that either, as I said, with the / or the R. A Unicode string has more values it can take on than the ASCII, the plain old strings, which are ASCII strings. That stands for American Standard Code for Information Interchange. In that, each character is 1 byte, and there are only 128 possible characters. In ASCII characters and plain strings, you cannot represent characters from other languages. Like this is a mark that you might see in another language. You can't represent that with your plain strings. So that's where the Unicode was brought in, so that, say for example, Hindi characters can be represented. There's lots of Chinese characters, and those can all be represented with Unicode. So you'll see when you're using ArcPy that a lot of the variables will print out as Unicode types. That's how they've encoded them. Here's a link to some more information. There are several common string operations that we'll be using a lot. First one is indexing, and remember that if you think of your finger, your index finger, that's what this does. It points to part of the string. The index string finger is for pointing, and so is indexing in Python code. So it points out the character that is index 3. Strings are 0 based, and so it's counting 0, 1, 2, 3. So that's why it's printing out D and not C, because it starts at 0. We've done a number of examples that have used concatenation, and that's putting strings together. Here we're putting the A, B, C, D, E together with the soup, and it just puts them right together without any spaces in between. Slicing is another operation that can be useful. This takes, instead of just 1, just points to 1, it can take a range of characters in your string. Notice that, so we're still using 0-based indexing, and we start with 1, so we get B, and then we go up to 4. So 1, 2, 3, 4, but we don't get that E because the right side is exclusive, left side is inclusive. So it goes for the 1, 2, 3 indices. We mentioned earlier that you can find the length of a string by using len and parentheses and the string variable inside. This is one of Python's built-in functions, just like round and min that we talked about last time. You can also check for membership in using the in keyword. And what that does is it says, is this substring contained in the string that we're looking at? So if we say ABC in Y, it's going to be false. If we say ABC in X, it's going to return true. Those true and false are those Boolean built-in constants that we talked about before. I mentioned earlier that we would talk about casting. The example that we did last time with add.py had casting to integer from string. So if we passed in the values 2 and 3 and printed the integer conversion of the two arguments, we would get 5. Casting converts a variable value from one type to another. The casting functions are just built-in Python functions. So there are int, float, string, list, set, dictionary, all kinds of functions that you can use to convert from one thing to another. Now, of course, it has to be the value that you're trying to convert has to be something that's convertible in that way. The 6 in quotation marks is convertible to an integer value of 6. 3.8, the number, is convertible to the string 3.8. This one converts the string quote negative 6.25 into the float negative 6.25. This one tries to convert the string foo into an integer, and we get a value error exception because what integer is foo equivalent to? We don't know. How would you use this in geoprocessing? Well, an example that commonly arises is to set the measurement unit for a tool that you're running. So for example, the buffer tool, the near feature, are using a numerical value along with a unit. In our example here, we have num equal to 3.8 and unit equal to the string kilometer. So 3.8, the data type of that is float because it has a decimal point in it. And if we try to concatenate these two values, num plus unit, so that we can specify a 3.8 kilometer buffer, for example, we are going to get a type error because it doesn't know what to do. Should I be addition or should I be concatenation? I've got a number on one side and a string on another. I'm all confused. I won't do anything. That's what Python says. So that's when you can use casting. You can't convert the unit to a number, so you've got to convert the numerical value to a string, so they'll both be the same type. Specify the buffer distance as 3.8 kilometers. The tool is going to require you to pass it in as a single string. So we can do something like this. str of num, and that's doing the casting to string. We can concatenate it with unit. Can you tell what this is doing? This is actually making sure that the space appears between these two. If you omit the space, you'll have 3.8 it'll be right smashed up next to each other, and the tool won't know how to interpret that. An example of when you might want to use something like this is in this code, which we'll go over in more detail, things about batch processing. But in this code, we're trying to batch process a single file. We want to try various different buffer zones with a distance ranging from 1 to 5. So each time we have to set the value of the buffer, we need to use a variable for the numerical part of the buffer specification, because we need this to change as we go along. So here we're looping through, and the first time it goes through, it creates a 1 kilometer buffer. Should be mile to go with the rest of the example, sorry. The second time it creates a 2 kilometer, and so forth, all the way up to 5 in this case. This is exclusive. And it loops through, and it's calling the tool, and it's setting the output name based on the distance value, because that's updating each time. More detail on that coming in another lesson.